Hey guys, it's Sheldon again with another video update on DaVinci Flight. This time I'm going to be showing you one of our new educational missions focused on energy. The first thing we need to do when we get in the game is to load up this mission. There are two ways to do this. First, you can approach the table in the mission room and a dialog comes up saying that we can press E to select a mission. Press E and the mission select screen will come up. Second, you can reach this screen through the escape menu. Below the active mission button is a new button that lets you select a new mission. Click that and then the select a new mission button in the window. You can do this from anywhere in the hangar bay. Once you're on the mission select screen, select Energy Mission 1. You have to click the image over here on the left. Clicking the text won't do anything. Then you're brought to the Mission Accept screen. You can read more about the mission, go back to the Mission Select screen, or accept this mission. Once you do accept the mission, a cutscene launches setting up a story for the mission. If you've already seen the cutscene and you want to skip through it, you can press escape at any time during the cutscene to return to the hangar bay. Once you've loaded the first energy mission and watched the cutscene, we've got a pink marker pointing out the flight sim at Design Terminal 1. We can go up to that, press E, and click yes to launch the flight sim. Once it's loaded, press launch. This will launch you at the start of the challenge course. There are 3 beacons that you must activate with markers to guide you, and a number of waypoint rings that will help you reach the beacons. Note that you can activate the beacons by flying through them, flying close to them, or flying over them. The first thing you can reach after launching your vehicle is one of these blue waypoint rings. When you pass through it, you'll notice your vehicle accelerates and starts to climb. That's because these gates provide a force boost for 10 seconds after flying through them. The force boost upsets the trim state of your vehicle and can cause your vehicle to climb at a very high angle or even flip over. In order to climb efficiently while maintaining forward momentum, easing the transition back into gliding after the boost has ended, I find it best to try to keep my glide angle below 45 degrees. You may have to provide significant nose-down elevator control to do this, so be ready to nose down as soon as you pass through the gate. After you pass through the first gate, you should be able to reach the first beacon without much problem. Beyond that, you can see the marker for the second beacon. It's quite a ways away, so point your glider in the right direction and settle in for a few minutes of glide. Note that if you're using a joystick, you may have some small, non-zero control surface deflections resulting from your joystick not being perfectly zeroed out. We're working on fixing this with a joystick zeroing function, but for now it can be helpful to Alt-Tab during long glides to keep your control surfaces at 0, or you might not end up pointing where you wanted to, and it will cost you a lot of valuable energy trying to correct that. Keep in mind that if you're playing the game at full screen, you won't be able to Alt-Tab and keep your eye on your glide progress. So if you've got the screen real estate, you might want to try playing in windowed mode for this mission. But even if you try to glide as efficiently as you can, getting to the second beacon you might find is just out of your reach. In fact, you should find it out of your reach unless you fire your boosters using the F key. And that's perfectly allowed, but if you're burning fuel to get to beacon 2, you're not going to be able to reach beacon 3. The idea is to get to beacon 2 without using your rocket booster so you can save energy to climb to beacon 3. But you probably can't glide all the way to beacon 2 with the given glider. That's because I gave you a bad glider. In real engineering, new designs often come out because there are design challenges that need to be met for which no existing or affordable design is particularly well suited. In this case, we've given you a rather mediocre design, but a course which demands a better design. So you aren't supposed to be able to complete this course, even with excellent piloting skills, with the given glider. Instead, note where your vehicle falls short, getting to beacon 2 for starters, and move on to part 2 of the energy mission by selecting Energy Mission 2 in the Mission Select screen in the hangar bay, and we'll investigate how we can improve our glider to reach beacon 2. In part 2 of the energy mission, we need to perform some analyses and make some changes to our glider in the design analysis room. If you're unfamiliar with using this tool, you might want to check out my design analysis room basics video linked on screen or in the video description. Basically, in order to reach beacon 2 without using our rocket boosters, we need to increase its gliding efficiency. We only start with so much energy, and then we get a little bit more from the first waypoint ring, but we lose too much to drag on our way to beacon 2. We need to get a greater amount of horizontal travel for every meter of altitude we lose. In other words, we need to increase our vehicle's glide ratio. You can read more about glide ratio in the included library book for this part of the mission, which is the first thing you'll be prompted to do when you launch this mission. That is Energy Mission 2. Glide ratio is a way of quantifying how efficiently our glider converts energy in the form of gravitational potential energy into horizontal travel. The glide ratio is the performance metric we want to improve, but we can't actually measure glide ratio directly without flying in the simulator and looking at our black box telemetry data. In order to iterate faster on our designs, we will want to be able to predict what our glide ratio is going to be by using tools in the design analysis room. Fortunately, the glide ratio is geometrically equivalent to another ratio we can easily measure in the design analysis room, the lift-to-drag ratio, or L/D. There's a diagram in the mission's library book which helps illustrate the relationship between glide ratio and L/D, and walks through one way the glide ratio can be derived using algebra and trigonometry from the lift-to-drag ratio. The library book also lays out for us the situation in terms of getting from the top of beacon 1 to the bottom of beacon 2, and we learn that we need a glide ratio of 22. So we need to iterate on our design in the design analysis room until we've got a glider that will steadily glide with an LOD of at least 22. There are 3 ways I'd like to show you how you can achieve this, although there are others as well. First is increasing the overall size of the main wing. This doesn't improve the wing's efficiency in any way, but because the wing produces almost all of the vehicle's lift, but other pieces of the vehicle are producing significant amounts of drag, if you make the wing larger relative to the size of the rest of the vehicle, like the tail or the fuselage, you will increase the overall L/D. This approach has a couple of drawbacks though. First, making your main wing larger with respect to the tail reduces control authority, and because the wing alone is unstable, a large wing tends to push the vehicle toward instability. So this approach can make your vehicle difficult to control and fly. Second, increasing the wing area increases the weight of the vehicle, and while weight doesn't have much direct effect on glide performance, so you'll be able to have no trouble completing this part of the challenge with a heavy glider, weight has a very significant impact in terms of how much altitude we can gain from the waypoint rings or your rocket boosters, so it will make the next part of the challenge very difficult. The second choice you can do is for improving your vehicle's L/D is to increase the aspect ratio of its main wing, or make the wing sort of long and thin. This decreases the effect of wingtip vortices acting on the wing, which improves its L/D and therefore the overall L/D for your vehicle. It does tend to make the vehicle more difficult to turn, but that shouldn't be a huge issue in this challenge. The last choice is to change what angle of attack your vehicle will naturally settle out at. L/D is highly dependent on what angle of attack you're flying at. If you fly at too low an angle of attack, you will generate a significant amount of drag just moving through the air, but you won't generate much lift. If you fly at too high an angle of attack, the wing gets close to stall, turbulence builds up, and while lift continues to increase, drag increases very steeply, so L/D goes down. But in the middle there's a sweet spot where you're generating plenty of lift, but not much more drag than you would be producing no lift at all. So you can control what angle of attack your vehicle settles out at by adjusting the angle of the horizontal stabilizer. Generally, you need a slightly negative horizontal stabilizer angle to keep the nose of your plane up. You can use a plot in the design analysis room with the flow solver node set to trim alpha only to see how L/D changes with horizontal stabilizer angle. Trim alpha only mode allows the flow solver to predict the settled out behavior of your vehicle before giving out its final results. So changes of angle of attack are being done behind the scenes to take into account the effects of changing the horizontal stabilizer angle. This allows your vehicle to glide efficiently without any pilot input, which will help you maximize your efficiency. Some combination of these 3 changes should be able to get you a glider with a glide ratio above 22, which will suffice for getting to beacon 2. Then we can move on to part 3 of the mission. In part 3, we'll look at the energy required to climb up to beacon 3. Using an energy balance taking into account the altitude we need to gain, an approximation of the drag on our vehicle, and approximations for how much energy we'll be able to extract from our rocket boosters and the waypoint rings that will help us on the climb, will predict how much fuel we need to load into our boosters in order to complete the course. All of this is outlined in the mission's instructional book in the library. You may think the trivial solution is to simply take the maximum amount of fuel allowed and then you may be tempted to skip this step. But our analysis will help us in two key ways. First, it will help us identify designs that won't work. If our analysis predicts that we will require more fuel than can fit in our boosters, we know right away that our design won't work, and we can try improving our vehicle design before wasting time trying to fly something in the flight simulator that isn't going to make it. Second, it can help us identify how much fuel we can get away with leaving out. Fuel adds weight, and that weight has to be carried for the entire flight leading up to when we burn that fuel. If we don't need extra fuel, we'll actually be better off not taking it so we can save on weight. Speaking of saving on weight, the majority of the design portion of this part of the challenge will actually be in trying to reduce the weight of our vehicle so as to maximize the altitude we can gain from the waypoint rings and our rocket boosters. If we are finding in our energy balance that we can't pack enough fuel, we need to make our vehicle lighter. You already came up with a design that glides well in the last exercise, so here we really just want to scale that down. Keep your aspect ratio approximately the same, but reduce your wing area. Once the wing is smaller, you can make the tail smaller. Once the tail is smaller, reduce the length of the fuselage and bring the tail closer to the wing. Then you can reduce the balanced mass required while still maintaining a favorable CG location. Although to be sure to recheck your L/D versus horizontal stabilizer angle plot to keep that correct, as the optimal angle will change when you make other vehicle changes. And if the peak L/D is below 22, you'll need to increase your aspect ratio or other things to keep the glide ratio good enough to make it to the second beacon. Once you've got a light enough vehicle that the fuel required is below the maximum fuel limit, and you're still maintaining a glide ratio of 22 or above, try out this portion of the course. If you can make it to Beacon 3, you're ready to move on to Part 4 and try completing the whole thing, beginning to end. If you struggle completing the whole course, even after you've completed Parts 2 and 3, don't give up right away. Head back to the design analysis room and make some more changes. You've sort of learned some of the ways that you can improve your design, and so you just sort of need to refine some things and balance things between the requirements for Part 2 and the requirements for Part 3, and practice a little bit of piloting skill, and you should be able to complete the course. Alright, that about wraps it up, guys. Thank you very much, and enjoy DaVinci Flight.